Hello students, friends. Today you can see about this session 43. In this session you can study about the transistor applications, that is oscillators, the condition for oscillator circuit, then transistor as an oscillator, and comparison between amplifier and oscillator. Now first you can see about oscillators. An oscillator is a circuit which produces a continuous repeated alternating waveform without any input. That is, without any input you can get the continuous output. Oscillators basically convert unidirectional current flow from a DC source into an alternating waveform. Means DC is converted into AC, which is of the desired frequency as decided by its circuit components. What you can say oscillator? Oscillator is a circuit which produces a continuous repeated alternately waveform without any input. There are different types of oscillators. So oscillators may be classified by types of signals they produce. The sine wave oscillators produces a sine wave output. Stable multivibrators or relaxation oscillators produces square wave and rectangular pulses, and sawtooth waves can be produced by sweep oscillators. So these are the different types of oscillators, depends upon the output waveform. Sine wave can be produced by using sine wave oscillators. Square wave can be produced by using stable multivibrators. Sawtooth waves can be produced by sweep oscillators. So these are the different types of oscillators. Now I can explain about the transistor as an oscillator. So last class I explained about the feedback and types of feedbacks. There are two types of feedbacks. One is positive feedback and negative feedback. So positive feedback is called regenerative. So why it is called regenerative? Because it reduces gain. Positive feedback reduces gain. It increases gain, and therefore it is called regenerative. It increases gain, hence it is called regenerative. Whereas a negative feedback, it reduces gain, and therefore it is called degenerative. So positive feedback is called regenerative, whereas negative feedback is called degenerative. Now you can see here the simple circuit. I explained the block diagram. So this is the input signal, that is signal Vs, and Vi is the input signal with feedback. So you got here output, and fraction of the output is again given back to the input by using this feedback circuit, and the output will be observed across this. Now in order to get the oscillator circuit, you have to see about the Barkhausen criterion. The Barkhausen criterion should be satisfied by an amplifier with positive feedback to ensure the sustained oscillations. So in order to get a circuit becomes oscillatory, it must satisfy the Barkhausen criterion. So what criterion? Barkhausen criterion. The loop gain, that is beta A, must be equal to 1. Means the equation for the feedback gain, AF is equal to AV upon 1 minus A beta. If 1 minus A beta, 1 minus 1 is equal to 0 becomes, the gain becomes what? Infinite. And therefore the loop gain is equal to what? Unity. Then only the circuit becomes oscillatory. And one more, the phase shift around the loop is equal to, the phase shift around the loop is 0 or integral multiple of 2 pi. Means the phase shift between the output and whatever the signal you are feeding, input signal and the feedback signal, both are in phase. So this is all about the Barkhausen criterion. So the Barkhausen criterion states that the loop gain is equal to unity and phase shift must be equal to 0 or integral multiple of 2 pi. Now this is all about the, briefly I explained how the circuit becomes oscillatory and what must be condition for the oscillatory. In order to get a circuit becomes oscillatory, you have to apply a positive feedback. Loop gain must be equal to 1 and phase must be equal to 180 degree. Now what is comparison between the amplifier and oscillator? Now first I will tell you what is amplifier. So amplifier is an electronic circuit which gives output as amplified form of input. So it is amplified form of the input. Means if the each signal is supplied to the input, the output becomes, you can get a large one. The amplifier does not generate any periodic signals. Amplifier uses negative feedback. Amplifier operates as a multiplier. The amplifier provides amplified signal and amplifier do nothing till input signal is fed to the input. So without any input you cannot get the output in amplifier circuit. Means this is one thing you can explain in amplifier. Whereas in case of an oscillator, the oscillator is an electronic circuit which gives output without application of input. Without application of input you can get output. The oscillator is generating periodic electronic signals. Oscillator is generating of the periodic electronic signal. In order to get circuit become oscillatory, you have to use positive feedback. The oscillator operates as a source. It gives us the oscillator signal. The oscillator produces signals from the moment of forward. So this is a comparison between the oscillators and the amplifiers. So what we explain in this session, how the positive feedback and negative feedback can be applied. So negative feedback is applicable to the amplifier circuit, whereas the positive feedback is applicable to the what? The positive feedback. The positive feedback is applicable to the what? The oscillator circuit. So it reduces. Positive feedback becomes called, it is regenerative, whereas negative feedback is called degenerative. So also I explained about the Barkhausen criterion and the condition for oscillations, and then the comparison between oscillators and amplifiers. So thank you.